What's going on, everybody? Welcome back to my YouTube channel. Look at this nice and beautiful question on the board that we're going to be solving. And the question says, find the value of x for which 8 to the x minus 2 to the x all over 6 to the x minus 3 to the x is equal to 2. Our first step is to simplify 8 to the x and 6 to the x. So 8 to the x can be written as 4 times 2. And this is to the x minus 2 to the x all over 6 to the x can be written as 3 times 2 to the x minus 3 to the x equal to 2. Now we're going to be applying the law of indices here, which says that when I have a multiplied by b and this is raised to a power, let's say n, the law of indices says the power affects the a, that means it is a to the n times b to the n. So let's apply that to what we have here in the numerator and what we have in the denominator. So this becomes 4 to the x times 2 to the x minus 2 to the x all over. Now the denominator, this is 3 to the x times 2 to the x minus 3 to the x, and this is equal to 2. Now our next step is to factorize. You notice that 2 is common in the numerator, so let's factorize 2. So factor out 2 to the x. Now 4 to the x dot 2 to the x divided by 2 to the x, and we have 4 to the x remaining, so this is 4 to the x minus 2 to the x divided by 2 to the x. I'm going to be having 1 all over. Now 3 to the x dot 2 to the x minus 3 to the x, you notice that 3 to the x is common, so we're going to be factoring out 3 to the x. So 3 to the x dot 2 to the x divide by 3 to the x, I will have 2 to the x remaining, so 2 to the x minus 3 to the x divided by 3 to the x, I'm going to be having 1, and this is equal to 2. Now let me simplify this 4 to the x. So this expression in the numerator can also be written as 2 to the x times, now 4 to the x is the same thing as 2 to the 2, that's 4, and this is raised to the x. So this is 4 to the x minus 1 all over. The denominator remains the same, so 3 to the x times 2 to the x minus 1 equal to 2. Now we're going to be applying the law of indices here, which says when I have, for example, a to the m and this is raised to another power, let's say n, this is equal to the two powers multiply, so that we have a to the m times n, powers multiply, and this gives us a to the m n. So which means that the positions of m and n does not matter. N can be inside and m can be outside, and in the end we have the same thing. So let's go ahead and switch the position of these 2 and the x. Bring the x inside and take the 2 outside, so that it looks like this, 2 to the x. Let's go ahead and do that. So this becomes 2 to the x times, now switching the positions of the power, we have 2 to the x raised to power 2 minus 1, close bracket, all over 3 to the x times 2 to the x minus 1 equal to 2. Now, you notice that we have difference of 2 square here, because when I square 1, it is still the same 1. So this is difference of 2 square. And how do we express difference of 2 square? For example, when I have a squared minus b squared, which is difference of 2 square, this is equal to a minus b times a plus b. So let's go ahead and express this in difference of 2 square. So this is 2 to the x times, now in difference of 2 square, this is 2 to the x minus 1 times 2 to the x plus 1. So we've been able to express this like this, which is what we have here. All over, now the denominator is 3 to the x times 2 to the x minus 1. And this is equal to 2. So 2 to the x minus 1 cancel out 2 to the x minus 1. So that we have 2 to the x times 2 to the x plus 1 all over 3 to the x to be equal to 2. Our next step will be for us to cross multiply, so that we have 2 to the x times 2 to the x plus 1 is equal to 2 times 3 to the x. Now, our next step will be for us to divide both sides by 2, so that we get rid of this 2 here. So divide the left hand side by 2 and also divide the right hand side by 2. So dividing the left hand side by 2, we're going to be applying the law of indices, because the power of this 2 under is 1. So the law of indices, which says when I have, for example, a to the m divide by a to the n, when it's dividing, I can just take one of the base, which is a, as long as the bases are the same, and subtract the powers, m minus n. So that's what I'm going to be applying here. You notice that the bases are the same, so I take one of the base, 2, and subtract the powers, x minus 1. So x minus 1. And this is 2 to the x plus 1 equal to, now 2 here cancels out this 2, leaving behind 3 to the x. Let's continue. Now let's say let x be positive, that means greater than 0. So when x is positive, now looking at this expression, you notice that this is odd and this is also odd. And there is nothing wrong with me multiplying 3 to the x by 1. It is still going to give me the same thing. So if this is odd and this is odd, it means I can pair this to this. That means 2 to the x minus 1 will be equal to 1. Now I want to make the base on the right hand side the same as the base on the left hand side. So this becomes 2 to the x minus 1 equal to, now the base here is 2, so I will write 2 here. 2 to the 0 gives 1. And now since the bases are the same, I can equate the powers. So the power on the left is x minus 1 equal to the power on the right is 0. And when I collect like terms, x will be equal to, as negative 1 crosses to the right, it becomes 1. So the value of x is equal to 1. And that is the only solution for when x is positive. Now, what if x is negative? So let's say let me use the word when x is negative. So when x is negative, we can represent x with any variable. Let's say let x be equal to negative u. So we're going to be putting it here into this expression. So this becomes 2, x is negative u, so negative u minus 1 times 2 to the x, x is negative u plus 1, and this is equal to 3 to the x, which is to negative u. Now, I'm going to be simplifying this in that you notice that negative is common, so we have to factor out negative so that we have 2 to the negative outside. So then I have u plus 1. So we've just factored out negative. So times 2 to the negative u plus 1. And this is equal to 3 to the negative u, which is what I'm going to be having on the right hand side, 3 to the negative u. Now, from indices, for example, when I have a raised to a power of a negative, that means if we have a negative power, this represents an inverse. That means it is same as writing 1 all over a to the n. And this is what we're going to be applying here on the left and on the right. So this expression can then be written as 2 to the negative u plus 1 all over, like I said, this is an inverse, which means it is a denominator because of this negative. So it is 2 to the u plus 1. You notice that the negative is no longer there. Equal to, we do the same thing here. So this can be written as 1 all over 3 to the u. Our next step will be for us to cross multiply. So on cross multiplying, we have 3 to the u multiplying 2 to the negative u plus 1, and this is equal to 2 to the u plus 1 times 1 gives the same thing, 2 to the u plus 1. Now let me go ahead and write this one again in another format. So we have 3 to the u times 2 to the negative u plus 1, and this is equal to, now from indices the powers add up, which means this expression comes from 2 to the u times 2 to the 1. So it is the same thing. So this becomes 3 to the u times 2 to the negative u plus 1 equal to 2 to the u times 2. Now, what we have on the right hand side is even. This is even, no matter the power we raise this to, and this is also even. But what we have on the left, this is odd, and this is also odd. You notice that the left hand side and the right hand side are not the same. So there are no solution for when x is negative. So the only solution we have for this question is x equal to 1. Well, feel free to share your ideas in the comment section below. And if you enjoyed this video and have learned something from this video, go ahead and give this video a thumbs up. Subscribe if you haven't. Turn on the notification bell so you don't miss my upcoming videos. And like I always say, until next time, take care.